Live, yay! Hey, Renee. If you could move the key later on. But if not, you know.
Give you a hug.
That's not tea. Well, welcome the two of you, and those of you who are logging in soon. Double check my bandwidth today. Everything looks really good. I got a good night's sleep. That'll help as well. I'm ready for any questions you might have as far as today's exam that's coming up. You can sort of lay it out. We start with 4 definite integrals. Finite. Two antiderivatives. There's 3 questions regarding Gini index and Lorenz curve. Let's see, that's 5, that's 9. There were 4 questions sort of dealing with word problems. There's 1 area under curve. There's 1 area between curves. 4, 5, 6, 79, 10, 11, that's 15. There's 1 or 2 more. Yeah, while people are loading in, I'm gonna look at a quick preview here and see if I can figure out what those other 2 were. That way you'll know exactly what to expect. As always, you'll be able to find this in the file folder marked quizzes and tests. I think I'll try to remember to move that right to the very top of your screen as well. That way, first thing you see when you're logged in will be the quizzes and tests. And I have exam number 4 loaded right at the very top, just to make that much easier. Okay, so 4 definite integrals, area under the curve, antiderivatives, Lorentz curve, Gini index, word problem, 2-word problems, 3-word problems, 4-word, 5-word problems, I guess. 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep, that's it. There we go. That's the exam. So in the word problems, I don't have you do a lot of calculations. I just have you either write a sentence or write a definite integral that defines something. On the 4 definite integrals, you'll have to do with something that has some sort of a root in it. You'll have to look out for the some number over x. I think one of them will be a general polynomial, and then one will be e to a number times x. And those will be the 4 type of definite integrals. Antiderivatives, I throw everything at you. I think each of them have 3 terms. So constants, roots, exponentials, 1 over x's. 3 Gini index and Lorentz curve. One of them will be straight Lorentz curve. Lorentz curve, of course, tells you what proportion or what percentage of a population controls what percentage or what proportion of a wealth. The Gini index is a calculation you do with a definite integral, and yes, I will have you calculate that out. And then there's a comparison between Gini scores of 2 different populations, which one is more equally or less equally distributed as far as wealth or income are concerned. Word problems are the ones you can probably expect: area under the curve and area between curves. On those 2, I believe I asked you to set up the definite integral, but not calculate it. So I think about 4 of these, it's going to be really important to know how to use the equation editor. All right, can we do question 8, 9, and 10? Let's go through 8, 9, and 10, shall we? All right, so we got a really strong stream going out of my house today. Sorry about yesterday. I put some fine tuning on the exam this morning, and then I basically just changed the points around, and I took the test. It took me 11 minutes, which is about what I like it to take for a typical 50-minute class. You folks have 75, so that's an extra 25 minutes. It's a little more cumbersome working with the equation editor and that, but I think that should give you plenty of time as long as you have decent preparation going on. Okay, 8, 9, and 10. Well, might as well just start with going right down the list. Find problem 8 here, there's marginal cost. 8, find area bounded by, okay? So we have 2 functions. Here's one of them. F of x is equal to 2x plus 5. And if you know what that graph looks like, and we should, that's one of them we did earlier in the semester, slope of 2, y-intercept of 5. And the other one is y equal x squared, or g of x is x squared. Yeah. Did I really give you that one? Boy, that was mean. If that was a misprint on my part, I think I wanted to type something else in there. Oh well, we'll do it. So x squared, let's see, x squared is this. All right. So we got an area. It's right in there. In order to find out what the bounds are on our area, our a to b on our definite integral, we have to find where those 2 are equal to each other. So what is x squared equal to 2x plus 5? All right, yeah, find the area bounded by. So x squared minus 2x minus 5 is equal to 0. Well, there's no way to factor that, and that's surprising. I think when I wrote this, I probably meant this to be a 3 instead of a 5. I probably typed in the wrong number. And I'm not going to ask you to use the quadratic formula on today's test. So if there's a quadratic to solve, it's going to be easily factorable. So let me change this problem ever so slightly. Let's change this to 2x plus 3. Okay. So slope of the intercept is 3 instead of 5. That'll make that be 3. that'll make this be 3. And that way I can factor it a little easier. X minus 3, x plus 1. Or if you use the quadratic formula, at least there's not going to be any crazy root hanging around there. So the two x values are x is 3 and x is -1. Right? So there's that one, there's that one. And here's how I make sure I have them right. I'm going to plug -1 in both of these. They should give me the same answer back. -1 squared is 1. -1 times 2 is -2 plus 3 is 1. Sure enough, that's the ordered pair. When I plug in -1, I get back 1 for both of those. And I always like to do that little extra bit of checking if it's available. That way I can make sure I haven't screwed it up. Now I'm going to plug 3 in both of them. If I plug in 3 here, 3 squared is 9. If I plug in here 3, I get 6 plus 3 is also 9. So that ordered pair up there is the ordered pair 3, 9. But now I can set up the definite integral that's going to allow me to calculate the area between those two curves. So step 1, find out where they cross. Did that. Step 2, set up the definite integral. X value of -1 to an x value of 3. Upper function minus lower function. And with the graph here, I can tell that the line is above the quadratic. If I didn't know that, I'd choose some number in between here and plug those values in. So let's choose 0. I calculate f of 0. I calculate g of 0. G of 0 is easy. 0 squared is 0. F of 0 is also fairly easy. That's 2 times 0 plus 3 is 3. Notice the f function is above the g function. This is the bigger of the two. And it shows up there right there on the graph as well. Huh? So upper function, 2x plus 3, minus lower function, x squared dx. I don't really need to encase the lower function in a set of parentheses. There's just one term there, so I don't have to worry about distributing a minus sign. Antiderivative, oh, that's an easy one, isn't it? That's x squared plus a 3x minus 1/3 x cubed. So I raise the power by 1 and multiply by the reciprocal of the new power. Now I'm going to evaluate this at x equal to 3 and at x equal to -1 and see what I get. Well, plugging a 3 in here looks like that's going to be a 9 plus a 9 minus 27/3 minus a 9. It looks like I get a 9 when I plug that in. Now, and you might want to check my work on this one just to make sure I haven't messed this up. Now I'm going to plug in -1. I'll get a 1 minus 3 plus 1/3. So let's see, that's 1 1/3 minus 3. That's minus 2. No, it's minus 1 2/3. So let's say 9 minus -1 2/3. 10 2/3. So my apologies for giving you a problem there that wasn't factorable and would require the quadratic. I'm not interested in if you know how to use the quadratic formula on this test. We did that on the last test. This one, I just want to make sure you understand how this problem works. And on the area between the curves on today's exam, I'm just going to have you set up the definite integral. I've already checked to make sure you know how to do definite integrals in the first 4 problems. So there's problem number 8. Turn back to my live stream, see if there's anything else. Nope, so far not. All right, on to problem 9 then. Occasionally I make a mistake up here on the board and someone out there in the universe of math students is able to find that. So there's problem 8. Let's go problem 9, shall we? Find the area bounded by. Okay, x equals 5. There's the line x equals 5. Whoop, missed it just a little bit. There's the line x equals 5. F of x is 2. Y equals 2. There's that one. And then what's left over? 50 e to the -0.2 2x. Phew. Okay, if I plug in 0, I get 50. So let's clear the heck up here. It's a negative exponential, so it's got to come down something like that, I guess. All right, so now we're going to have to figure out where the borderline is. I can tell this, let's see, x is 5. Oh, okay. Probably goes something like that. So we're going to have to figure out where these two lines cross. So we have two functions of x. This is a straight line of x equals 5. These are our two functions of x. Let's see where they cross. F of x is 2, about as boring as you can get. And then the other one is g of x is equal to 50 e to the negative 2x. All right. Now the question is, do they cross after this x equals 5 or do they cross before? That's going to be a big difference to see how those two things go. So as always, we need to find where those functions of x cross. We'll set them equal to each other. When is 2 equal to 50 e to the negative 2x? I'm going to have someone out there help me out with this calculation because I didn't do it yesterday and I don't remember how it came out. Let's work through this as we should. Divide both sides by 50 to clear out the exponential. It's 0.0250. This is 4 out of 100. Yeah, 0.04 is equal to e to the negative 2x. That means that the natural log of 0.04 is negative 2x. So my x value here that I'd like someone out there to calculate is this. When is x equal to the natural log of 0.04 divided by negative 2? So someone out there, please let me know what x value that is. I'm having a feeling it's a number that's a bit bigger than 5. So again, I set those two equal to each other. I did a little quick exponential equation solving the way we've always done it. Isolate the exponential, then use logarithms. Remember, the logarithm asks what's the power. So what power of e is equal to 0.04? That's what natural log asks. It's negative 2x. But I need this. Oh, negative 2x. Yeah, negative 2x. Is that right? So I think I'm pretty well consistent with the negative 2x. Right? Yeah. So we need to figure out what logarithm is then. Grab up calculator and let me know what x should be. Oh, 0.2x. Oh, thank you. Gotcha. Throw a 0.2 in there. Nice. So I copied the problem wrong, evidently, huh? Negative 0.2x. Good. Good catch. Thank you. Got 1.61. It's definitely decimal. Yeah, it's going to be a decimal, no doubt. Anytime logarithms are involved, unless it's the natural log of e, which is 1, or the natural log of 1, which is 0, you're pretty well stuck with everything else being some sort of a decimal. 16.09. Thanks, Aaron. If someone wants to make sure that's right, I feel better about it. That seems to make some sense, though. All right, and then right with that 10 off. Okay, so now I'm ready to go. I have maybe my graph isn't the greatest here. Let me change my graph a little bit. So I have a 5. There's x equal 5. I have this function 50 e to the x, and then I had f of x was equal to 2. So this is the area that I'm looking at. We said it was 16.09, yep. So that's the place where they cross. Obviously by the graph, This one is higher than that. If you don't believe me, you can plug in any number in between here. Calculate g of 7, for example, and this number will be bigger than 2. So the upper function is the exponential function. The lower function is the linear function. They crossed right there. We had an early fence built up. X was 5. So now we have that, now we have that right where we want it. I'm double checking my work. Yep, X is 5. All right. Now let's set up the definite integral. Well, we have the X values where this area stops and where it starts. It starts right there at the fence at X equal to 5. And then it goes until X is 16.9. Upper function, oh, erased my equation, didn't I? Upper function was 50 e to the negative 0.2x. At what time I copied it right, I think. Yep. And then subtract off the lower function, y equals 2. There it is. Set of parentheses is always nice, and then a dx at the end. I'll be looking for that on your work today as well, making sure you have the dx in there. And a set of parentheses, if there's more than one term, is nice. All right, so on today's exam, this is as far as I'm going to ask you to go. Just write that definite integral, but we'll complete it for this exercise. So the antiderivative of this will keep the 50, we'll keep the e to the negative 0.2x. We'll multiply this by the reciprocal of the derivative of the numerator, negative 0.2. And then we'll take the antiderivative of 2, which is 2x. Evaluate that from 1609 down to 5. Dividing by 0.2 is the same as multiplying by 5. So this should be 250 e to the negative 0.2x minus 2x, evaluated from 16.09 down to 5. So someone, if you'd be so kind, plug the 16.09 in here, tell me what you get. And then someone also be so kind, plug in the 5, tell me what you get, and then I'll write out each of those partial things. So there's my antiderivative. I think I did that right. I'm going to double check it one more time. Divided by 0.2 is the same as multiplying by 5. That's 2/10, yeah, which is 1/5, which is 5. Yep, I like it. All right, antiderivative is good. Yeah, Brian, we'll get to number 5 in a second. You plug in 5, you get 81.97. Okay. And how about when we plug in 16.09? Oh, right. Oh, gotcha. Negative. Yeah, that's negative. Thank you. Now I see where you're going. Yep. Okay. Right. So yeah, so this would have been a negative 250. We're divided by negative 0.2, which makes this be a negative 250, which throws off both of those. Yeah, I was looking back at that thinking, man, that's got to be negative, otherwise it's not going to work out right. So both of these numbers have to be negative, and this one has to be more negative than the first. Sorry about that, Matthew. You have to do them both over again. Just go through everything else off on both of those. 5. What values are we going to get for each of those? Okay, negative 101.96. Good. And negative 42. Okay. So go negative 42 there, and then 102 there, I guess, huh? So 42 looks like that's about 80? No, about 60, yeah. So negative 42 plus 102 is right around 60 for the area between those curves. Thank you both. All right, on to the next one. So I'm going to double back. Brian wanted to see number 5. I think we were supposed to do what, 8, 9, and 10. As I got started, I'm going to check back on the chat just to make sure. Question 10, yep, and then 8, 9, yep. All right. I'll pivot to the newer ones after that. Okay, problem 10, the Lorenz curve. All right. So this is broken up into 3 parts. And this test is broken up into 3 parts as well. Find the Gini index for this country. Well, the Gini index will be the area between equal distribution of wealth, which is a line f of x equals x, and the Lorenz curve, which will be shaped something like that. So the Gini index will be double the integral from 0 to 1 of equal distribution, which is x, minus whatever the Lorenz curve distribution has, 1/2 x plus 1/2 x squared dx. Bring the 2 along because we can. Distribute and combine like terms. This becomes 1/2 x minus 1/2 x squared. If I distribute the minus sign through there, the first 2 terms are like terms, so 1 full x minus 1/2 x leaves 1/2 x. Distribute the minus sign and we end up there. dx, 0 to 1. Carry the 2 along. Whoops! I'm taking my antiderivative, and when I take my antiderivative, I lose the antiderivative sign. So I'm going to sort of wall this off. This would be 1/2 times 1/2 x squared, using the power rule there on x, minus 1/2 times 1/3 x cubed. Again, raise the power by 1, multiplied by the reciprocal of the new power. Raise the power by 1, multiplied by the reciprocal of the new power. So this is 1/4 x squared minus 1/6 x squared. I'm going to evaluate that from x equal 1 to x equals 0. And since these are polynomials, the 0 calculation is nothing. There's nothing there. So we have 2 times. Plugging in a 1, I get a 0.25. Plugging in a 1 in this one, 1/6 is, let's see, 1/3 is 0.3333, so this would have to be half of that, minus 0.167, I guess. Let's do the subtraction. 2 times 0.0253, 0.083. 0.166. There's my Gini index. not much of a curve there. Lower powers here tend to make that be fairly flat. That's why the Gini index is so small. The higher power there, the more belly it has, and the higher the Gini index will be. So there's the first part of that one. What proportion of wealth did the bottom 80% of the population control? That has nothing to do with the Gini index and has only to do with the Lorenz curve. Bottom 80%, so I'm going to do L of 0.8. If I calculate L of 0.8, it's 1/2 times 0.8 plus 1/2 times 0.8 squared. I just plug 0.8 right in the Lorenz curve. So this is 0.6, whoops, I'm sorry. This is 0.4 plus, that's 0.64 plus 0.32. That's 0.72, which is 72%. So in that country, the bottom 80% controls almost 80% of the wealth. So 72%. Part C, what proportion of wealth did the top 80% of the population control? Well, I know what the top 20% controlled. They controlled 36%. That was it. All the rest of it. The top 80%. I have no way of getting that directly, so I'm going to have to do 2 steps to get there. The top 80% is what the bottom 20% didn't earn, so or control as well. Yeah. So I'll calculate L of 0.2 first. This will be the wealth of the bottom 20%. 1/2 times 0.2 plus 1/2 times 0.2 squared. And 1/2 times 0.2 is 0.1. 0.2 squared is 0.04. So that's 0.02, 0.12, 12%. So the bottom 20% controlled 12% of the wealth. Therefore, the top 80% must have had the rest. The top 80% must have had 88% of the wealth. And the only other Lorenz curve question that I'm going to have on there would be like problem 11. City A has a Gini index score of something. City B has a Gini index score that is smaller. The smaller the Gini index score, the more equally distributed either the wealth or the income is. The larger the Gini index score, the bigger the belly. Underneath the equal distribution of resources is, and thus the higher the Gini index. The higher Gini index, less equally distributed. Lower Gini index, more equally distributed. Those are our 2 options. Now I'm going to back up. I think it was problem 5 that Brian requested, if I recall my numbers right. Yep, number 5 it is. And number 5 comes directly from one of the problems we did on one of the activities. So let's read down through this. There's the velocity, that's how fast she's going. And got that on 2 pages somehow, didn't I? So we're given a velocity function. I think I recall all those digits. I've written this one so many times. Yep. All right. So this curve gives her velocity, and that is in feet per second. This is the time, and that is measured in seconds. I think I had you write that on the last, on the activity. I had you write those labels. What is her velocity 15 seconds after she jumped out of the balloon? Well, this is the equation that gives it to us. I could read it right there if I wish. I could read it across 15 and have a really good indication. If I wanted to calculate it using the formula, I just plug in V of 15. And looking at the graph, I'm going to make that a little bigger because my eyes are old. Looking at the graph, that looks to be right a little bit over 170, 171 or so. Anyway, grab out your calculators. You should get something that's really close to 171, maybe 172. If someone wants to take the time and do that, that would be great. On to part B. How quickly is her velocity increasing after she jumps out of the balloon? Well, how quickly the velocity changes is going to be the derivative. So let's go v prime of t. That one goes away, so it's negative 185. Leave a little space there, e to the negative 0.173 t. Remember, on derivatives, we just bring the derivative of that power down, negative 0.173. And I did this one yesterday. That one comes out to be 32. 32 e to the negative 0.173 t. That's how quickly the velocity is changing. Now remember, when we're doing derivatives, it's always these units divided by those units. When we're doing antiderivative, it's the product of those units, as everything has been, set standing on its head when we started moving backwards. So if I calculate v prime of 15, 32 times e to the negative 0.173 times 15, I think this one came out to be in the vicinity of 2 yesterday. Now we need to get our units right. 2 feet per second. It's these units divided by those units. And looking at the graph, that tells us pretty much, if I waited a whole nother second, how much faster would she be going? About an extra 2 feet per second. And I'm not 100% sure if that was 2. I just sort of recall that from yesterday. So if someone wants to grab out their calculator and figure that one out for me, just to make sure everyone's on the same page, that would be good too. Sure, I'll put number 11 up on the board in a second. Okay. So there's feet per second. What's the gain in speed, feet per second? Another second later is about how you would approximate that. Write the mathematical expression that would find the distance she fell during the first 15 seconds. Easy enough. The area under the curve. Look at the units here one more time. Feet per second times seconds. Seconds units cancel. This unit times that unit means the area under the curve measures feet of fall. How far would she have fallen? Well, what is the area under the curve from 0 to 15? We calculate that by taking a definite integral. 0 to 15 of v of t dt. Or if you want to write that whole thing back in there, that's fine too. I write the mathematical expression that would find her average speed. Okay. Well, this is how far she fell in 15 seconds. So if I wanted to figure out what her average speed was, I just multiply that by 1/15. Alternately, I could have written it like this. That whole thing divided by 15. So this is how far she fell, and this was her average speed. Units here would be feet per second. Units here would be feet. And I will ask you to make sure you write the units and write them with the appropriate units. That'll be part of the scoring. In fact, it'll be a fairly significant part of the scoring. Okay. So here's how I would represent her average speed. I calculate whatever that is. I can draw a line right across here from 0 to 15. I know I have it in the right place. If the area where the function lies over this designated average speed is the same as this area over here. So I could calculate it using calculus here, and I could know right exactly what it is. Or I could sort of eyeball it as well. I'm going to ask you to do the eyeballing on one of the questions today. What does the graph in the shaded region represent? Well, the shaded region isn't exactly on, probably at where I wanted it. I think I copied this from a different, well, obviously I copied it from I copied this from the activity. So let's, if there's one, yeah, there will be one. On today's exam, I'm going to put, if there's a shaded region, it's going to be solidly on some numbers so that we don't have to guess. So let's move the shaded region ever so slightly. Let's say that starts at 20 and ends at 30. I'm not going to mess around with little decimal-y things. Oh, 35. Yeah, okay. Let's say it ends at 35 because that's fairly close. I think that's what I was aiming for when I did the copy paste of this one. So this would be area under the curve is again measured in feet. How far the skydiver fell. In the time interval. From 20 to 35 seconds after jumping. Area under the curve will be measured, we'll measure how far that skydiver fell. So that wraps up all of that problem. I think I'm going to double check. Yep, that was part E. We want to go do number 11 to make sure we got the sentences. Sure. Since we were there just a second ago, it probably makes sense to go back. Okay, city A has the bigger of those two numbers, doesn't it? So since city A has the bigger of the two numbers, that means the area between equal distribution and their situation has a bigger area. There's a bigger demarcation between those two. So city A has, so it's a bigger number, has less equal distribution of, and now we have to be careful with wealth versus income. This is wealth. And city B, alternately, city B has a more equal distribution of wealth than city A. Either of those will be just fine. Okay, bigger the number, less the less equal the distribution. All right, I'm going to look back up in the chat and see what I've missed here. Number 5 we just did. Number 4, okay. I think I've caught up with everything else, right? Question 10, 9, 8. Number 5 we did, that was the jumping out. Number 4 is next. Okay, and we finished up 11. Write an expression, I'll give the average value. Okay. Do no calculations. Do not calculate the average. Just write the expression and find it. Well, I'm not a whole lot sure about this function. I don't really. 4 to 7, I don't know. It's up here someplace. There's 4, there's 7. I don't even know. I have no idea what that graph looks like, by the way. That would be an interesting one to graph. What could that possibly be? Jeez. Oh well. It's got some sort of curve to it. So what I'm going to do first is I'm going to calculate the area under the curve, calculate that whole area, and then since this is 3 units wide, I'm going to divide it by 3. So how do I calculate the area? Well, I'm given my limits, 4 to 7. Here's the natural log x times e to the x dx. And by the way, you have no way of figuring this one out. Not only do you not know the antiderivative of natural log, there's a product there, and there's absolutely no way that you folks do that. But that would be the area under the curve. If I want to diminish that by a factor of 3, I could either write it this way, or write it that way. So what that would do is take that whatever sort of curve I have here, you'll be able to replace that with a straight line, a straight horizontal line. And that straight horizontal line would be such that the area under that straight horizontal line, the area in that exact rectangle, would be the same as the area under the curve between 4 and 7. So if you understand how these work, this is one that you can look at the problem, you can write this and go on to the next one, and this should take, okay, it's going to take a little while to get the equation editor up and going, I suppose, and fiddling around with it, but this is a 2-minute problem at the longest, I would think. All right. You have to talk about both. No, but you do have to understand both without giving the question away. You said city A has less equal distribution. Yeah, that works. $11. 2D it is. So here's the one case where the power rule doesn't work. I could, if I wanted to, write it that way. And maybe then it's a little more clear what function has an antiderivative of 1 over x. Well, that's natural log. So this is 4 natural log absolute value of x. Absolute values aren't needed because both these are positive numbers in this case, but had both those been negative, then we'd have to use those for sure. So from 7 to e. Okay. Plug in 4, you get 4 natural log of 7. That's something I don't know. Minus 4 natural log of e. Now remember, natural log of e asks e to what power is e, so that's just 1. So grab out your calculator, calculate 4 natural log of 7. Once that's done, subtract 4 from it, and you'll have the area under that curve 4 over x from 7 to e, or you'll have the number that represents that definite integral. So there's 2D. So yeah, watch out for this case. Oftentimes I'll have people write this as 4x to the negative 1, and then they'll try using the power rule. They'll raise the power by 1, which is easy enough, but then multiplying by the reciprocal, it's that old 1 over 0, which is undefined. And I'll have a few students that just throw up their hands. This is the one and only case where the power rule doesn't work. So if you see that, you should realize that something's going on here. Let's go back and use natural logs there. I think that happens at least twice on the exam today. pretty sure I'm through everything that's been asked so far. Ready for the next question. One E, sure. This is a general antiderivative. Copied right, yep. Oh, 5 and 4, I would maybe think of it this way. 5 over 4 is a constant multiplier. Beautiful thing about the derivative and antiderivative of e to the t is e to the t. And of course, on the general antiderivatives, putting the plus c at the end is going to be important. Welcome. Did you get it right? Good. Wow, that's a, you talk about easy one to check. There it is, right? It's a derivative of 5/4 e to the t. Yeah, 5/4 e to the t. Let's have that in your back pocket also if you remember how to take a derivative. So you work through these antiderivatives. In my estimation, 90% of you will have plenty of time on this test. So those first 6 questions, I'm asking you to take an antiderivative somewhere along the line in those. So you can check your work by looking at your answers, taking the derivative of those answers, and make sure that ends up where this question started. 1H it is. So here we have t that's in the denominator, and it's not the first power. So here we can use the power rule. So my suggestion on problem number or letter H would be to rewrite this. And I'm going to take I'm not going to write the original problem back up there. I'm going to write what I would see right away. The 6 and the 7, those are the constant multipliers. That's t to the negative 2.4 dt. Why negative? Because it was in the denominator. Now I'm ready to use the power rule. Raise the power by 1, negative 1.4, multiplied by the reciprocal of the new power, negative 1 over negative 1.4, then plus c. That's 9.8, so I guess this would be negative 6 over 9.8. I could drop that t back to the denominator, I guess. T to the 1.4 plus c. And on today's exam, I'll be happy if you even leave it like that. That's fine. I just want to make sure you understand the antiderivative rules. Do remember the plus c on those 2 general antiderivatives, however. Next question, if we have any more questions. But what an easy one this is to check, huh? Bring that down, reduce the power by 1, yeah. No, the only question is, can you do that rewrite step first? We probably got out of practice a little bit with that last test. There wasn't a lot of rewriting on that last test. Certainly we did a ton the first couple. I heard from, I think, 3 people who were unable to take today's test when their class started. I've made arrangements with each of those 3. One will be taking it early, 2 will be taking it a little late. I'm hoping to have the answer key open by probably about, probably first thing in the morning, I would say. Yep. Problem 4 and problem 3 coming up next. We already did 3, did we not? Oh no, the area under the curve. Hang on a second. Yeah, we did 4 just a second ago. I'll do 3 and 4 because they're pretty much tied together. Area under the curve for the interval 4 to 7. Do not calculate the area. Well, I know both natural log and E give us positive values in the interval 4 to 7. So again, I have some graph of natural log e to the x. I don't know what it looks like, but there's a graphical representation of what it might look like. I don't know. I need the area under the curve. To get that area under the curve, I go from 4 to 7, take whatever function I'm given. In this case, it's natural log x multiplied by e to the x dx. There is the area under the curve. No more calculations are needed. And problem 4, I want the average value. If this is the total area under the curve and it's 3 units wide, I can even out the curves here by taking this and multiplying it by 1/3. So there's problem number 3, and there's problem number 4. Good one. Any more questions? All right, I guess I'll just wrap this one up then. Good luck to everyone on the test today. If you want to see, exactly the layout of the tests, I covered that in the first several minutes of class. Feel free to close this down, watch it from the beginning. Take your time on it, and make sure you double check your work. Right? All right, I'm signing off. Any last minute questions? Oh, 1F. Sure, Connie. Any last minute questions? Feel free to send me an email. 122 e to the 4t dt. Well, I could bring the 122 up front, I suppose. And now I'm ready to take my antiderivative. Keep the 122, keep the e to the function as it was before, put the plus c at the end so I don't forget it. Now remember, when we take the derivative of this, we bring down the derivative of the power and have it as a multiplier. So taking the antiderivative, we're just going to stand that on its head. We're going to bring down the reciprocal of the derivative of that power. So 122 times a quarter would be 30.5 e to the 4t plus c. There it is. Now I've noticed that some people are still putting an antiderivative sign in front of their work after they've taken an antiderivative sign. I think maybe 10% of us were doing that on the quizzes. Don't. If you have the antiderivative sign in front, that means you still have to take an antiderivative. So now I can check my work on this easily. What's the derivative of e to the 4t? Well, I bring the 4 down. 4 times 30.5 is 122. And that one's guaranteed to be right. Get a nice, easy check. And there'll be nice, easy checks on each of those. Especially easy because we did not cover integration by substitution. So, power rule, exponential rule. Don't even have to remember the chain rule on most of them. This is the only case where we even attempted one that working backwards, working the derivative way, you'd have to use the chain rule. Anything else, anyone? The major issue in the past was people didn't understand the word problems, how the units worked, what the average measured. If you have that down, that'll certainly be a leg up. And since we didn't cover the really difficult antiderivatives, since we didn't use the substitution rule, hopefully those antiderivatives will go fairly smoothly. Anything else? All right. Good luck this afternoon. It's lunchtime for me. Again, if you do have any last minute questions, send me an email. I'll get in touch with you. Bye now.